There are challenging problems all around us. We find them at home, at work, and of course in school. But to engage in critical thinking, what many refer to as higher order thinking, the problems students need to tackle are complex. Some of these problems may not even have a correct answer or a single correct answer. They require students to have a firm grounding in subject knowledge and skills before they can think critically about them. The emphasis in critical thinking and problem solving in these cases is on the processes students use to explore a challenging problem, to present solutions, and justify their choices. As teachers scaffold students from teacher directed instruction to more student centered learning, the types of problems students engage with can change in terms of complexity. Yes, we want students to be able to address complex real world problems, but if we haven't prepared them with the appropriate foundational content knowledge and skills, they won't be able to think critically or pose reasonable solutions. You can obtain a complete copy of the tip chart from the link in this page, along with a searchable database of lesson ideas on Henrico 21. There are different models to describe the level of rigor or cognitive demand of tasks, both in and outside the classroom. Bloom's taxonomy and the revised version are popular frameworks. More recently, the work of Norm Webb has been used to describe cognitive demand through the metaphor of considering how knowledge is used. Please note that activities at higher levels are not considered better than those at lower levels. Depending on the content, all four levels may be addressed within a unit of study. A brief description follows in case this framework is new to you. DOK1 stands for Recall and Reproduction. Students have to comprehend basic content knowledge, which can include important content-specific concepts, processes, and rules, not just vocabulary and facts. In DOK2, Basic Application of Skills and Concepts, students respond to questions or problems that require them to apply the content knowledge they've acquired. DOK3 refers to strategic thinking. This use of knowledge goes beyond rudimentary and known problem solutions to require students to apply content knowledge at a deeper level, often involving complex real-world applications in which students pose and support their solutions with evidence. DOK4 refers to extended thinking. Students move to using and thinking about their own content knowledge and skills so they may actually generate new understandings about their knowledge within and beyond the content area. DOK4 is often associated with metacognition and self-reflection. Eric Francis, writing for ASCD, suggests that the popular wheel of verbs doesn't go far enough to design learning opportunities that reach the intended rigor of DOK levels 3 and 4. Instead, he provides questions that both teachers and students can use to scaffold their thinking. Now that you've had a chance to explore the critical thinking and problem solving element of the tip chart, note how Norm Webb's depth of knowledge levels neatly fit each of the four categories. I proposed this idea years ago and have explored it in dozens of schools with hundreds of observers in many, many classrooms. The match fits well. Therefore, if you have content standards that suggest a level of DOK or 3 or DOK 4, consider using this component of the tip chart to plan your learning. Use these questions to review at least one of the associated videos. You'll find a secondary and elementary video that does address this category of the tip chart, at least to some degree. Or you may want to seek out additional videos on Henrico 21. Please note that we're very thankful to the teachers that open up their classrooms for these videos, but they are real classrooms. Sometimes things go well, and sometimes there are things that we learn from. Just because a video is included, it doesn't mean that it's the only example of how to address the tip chart. They are included here as conversation starters to explore the tip chart and reflect on your practice. Students who are developing foundational knowledge and skills in any content area still need to learn how to use the proper vocabulary and demonstrate subject-specific skills. Academic exercises can help students build these foundational skills. However, since the ultimate goal of learning is transfer, being able to use new knowledge and skills in novel situations, it's important to prepare students to use those skills and knowledge to address real issues or problems in that content area, or to address problems worth solving. Grant Wiggins and Jay McTighe explicitly describe the difference between academic exercises and challenging problems in their popular Understanding by Design model. Problems go beyond a sheet of questions or proofs. Many word problems, too, are actually academic exercises presented with words rather than formulas. What are the problems in your content area that you are preparing your students to solve? What knowledge and skills do they need to address complex problems? Educational experts and researchers from Project Zero at Harvard suggest that students must be given an opportunity to engage in what they call thinking moves. Students can implement thinking moves at different levels, but as students become prepared to address complex problems using the content they are learning and the thinking moves they are developing, they'll be more prepared to engage in critical and creative thinking and posing innovative solutions to complex problems. You can learn more about these from their book, Making Thinking Visible, or visit their webpage with lots of free tips. Performance tasks aren't a new idea, but what is new is the increasing availability of digital devices available to classrooms that provide access to the same or similar tools, resources, and information that can be found in real-world settings. Performance tasks are also becoming more prevalent in high-stakes testing, as many states and even the College Board are promoting the use of performance assessments in class and in end-of-course assessments. Performances don't require a stage. They simply require an opportunity for students to use their knowledge and skills in an authentic manner. The best authentic assessments are those that engage students by being interesting and relevant to their own lives. You may want to explore one or more of these performance tasks created by real teachers at many different grade levels from across the country. They're linked on this page. Concept maps, flowcharts, graphic organizers, data visualizations, infographics, and other visual ways to organize our thinking are great tools to promote critical thinking. They are appropriate visualization tools for students of every age and that fit every content area. If you haven't already, review the document summarizing a review of literature on additional ideas of what students should be able to do in support of critical thinking and problem solving, as well as activities, processes, or strategies you can use in your classroom to help students develop these skills. Consider which strategies you're already using and any that you want to learn more about. You're encouraged to explore some of the ideas in the literature review on your own. If there are terms or strategies that you're not familiar with, how might you find more information? Are there knowledgeable experts in your building or district you can talk with? Do you have PLCs or study groups that might be interested? And don't underestimate the value of a good internet search. Now that you've reviewed some examples, a few strategies, and part of the research background on strategies that promote critical thinking and problem solving, consider what you want to do in your classroom to help students develop these skills. Do you want to tweak existing strategies or try something new? Use the tip chart to plan and monitor a lesson activity that promotes creative thinking and innovative problem solving. Consider whether you want to design a new lesson or redesign an existing activity.